Hello everybody, thanks for coming. Today we're going to go over the fairly simple process of creating this sunglasses models. And I'm going to modify it a little bit from the courseware that we use in the training sessions. I'm going to simplify this a little bit, but what you're going to end up with is a model that has a lot going on in it. There's some very complicated shapes that are happening in this model that T Splines allows you to create very simply. And the glasses that we're going to do, the temples area is going to be simplified a little bit, and we may leave out some of the more advanced features as far as creating some of the details and stuff like that. But what I wanted to show you was how you could create an extremely complicated form such as this with just a few tools, and then if you want to come in and get into the more advanced features and stuff like that, you can start, getting into the finer details. So let's just go ahead and jump in. I'm going to shut the final model off here, and I'm going to show the curve that I'm starting with. This is essentially the building block for the entire model. And what we have here is a head that we're going to use to fit these glasses to. And one of the beautiful things about T Splines is as your model is being built, you can modify it and work with it easily enough that you can kind of change the fit and change how it interacts with the head here on the fly and get some visual feedback by just going inside the model and checking for collisions to make sure that everything is going to work. This would be kind of difficult to do if you were modeling this in NURBS, because obviously you'd have a bunch of trimmed and blend and surfaces, and you'd have to go back and try and modify each one of those, and it usually would require you to trim and untrim and blend and reblend and all that kind of stuff in order to get it to fit. Here we can just grab stuff and bend it around until it works and be in and out of there quick. So we're going to aim, the webinar is scheduled for about an hour. I probably am not going to need that much time to build this, and if all goes well, and then so we should have plenty of times for questions and things like that at the end. So let's go ahead and jump in. I'm going to shut the head off at the beginning here, and you'll notice that this is all going to start with a single curve. And basically what we're going to do is bring up the heads-up display, and that can be accessed through, my toolbars are hiding here. Oops, no, not that, sorry. That can be accessed through hitting the translate button here. If my heads-up display was off, if I hit this, it would bring it up. Underneath here, we have translate, rotate, scale, and set pivot. That can all be accessed from the toolbar or within the translate, within the heads-up display system itself. If I click on the names in the, why is that not working? If I click on the name, it should change from translate to rotate. There we go. Rotate, scale, and if I hit the T key, I can change and snap where my pivot point is, which allows me to manipulate the object. Familiar kind of gumball modifiers. So let's go ahead and get started. I'm going to pick this object, and I'm going to scale it from the center, holding down the Alt key, which is going to create some geometry. And you'll notice that this is just extruding this curve out, and as I drag holding down the Alt key, I'm creating a surface. And if I let this go, you'll see that I've just created a T Splines surface. If I pick that, you'll notice here that it says that it's indeed a T Splines surface. So my next step on this is going to be to thicken it, and basically what I'm going to do is I'm going to click on this. I'm going to come to my T Splines toolbar. I'm going to hit the thicken button, and I can either drag a thickness and specify a thickness, in this case, I'm just going to drag because we're going to do this simply. But you could specify if you were working in inches or millimeters, you could specify how many millimeters or how many fractions of an inch you wanted this to go. In this case, I'm just going to drag out and hit and click to accept. And you'll notice that I've created a piece of T Splines geometry here. This, as it sits, is watertight and is suitable for rapid prototyping or data transfer or anything like that at this point. But obviously it's not glasses yet. So what I'm going to do is I'm going to switch to box mode. There's two modes in T Splines, and those of you who downloaded this and started using it may notice that there's a smooth mode, which is the visual representation of what the interpolated surface looks like. And then there's box mode, which if I switch up here, if I hit the smooth toggle button, you'll notice that it shows the polygonal representation of what the model actually is. Box mode may be an easier form to work in when you're getting started because everything's fairly clear and fairly well laid out. If you look in your box mode, if you're having problems with your model and you look in your box mode and something's really screwed up, like there's verts that are crossed up or there's a face that's turned inside out or something like that, you can be fairly assured that that's going to be the problem. If you go ahead and address that issue in box mode, when you go back to smooth mode, that problem will most likely resolve itself. So this is going to be a symmetrical model, obviously, and I need to build the bridge, and there's a couple of ways I could do that. I could either extrude a piece out and then mirror the whole model, but in this case what I'm going to do is I'm going to work on this edge right here. And right now, if I look at it if I turn on my vertexes, if I move this, you'll notice that they all go together. Well, what I want to do is I actually want to open this edge up. So I'm going to go to edge mode. I'm going to bring up my toolbar, and I'm actually going to right-click on merge edges, which is going to be unmerge edge. So I'm going to unmerge that edge. Now, if I grab this edge, you'll notice I can move it, and it's no longer attached. Well, that's not quite what I want. What I want to do is I want to have this edge here attached, but I want this edge out here open. So I've just unwelded the entire thing. So what I'm going to do is I'm going to turn on my verts, and I'm going to grab this vert. Notice there's two here because I unwelded it. So there's two verts stacked on top of each other. And I'm going to weld those points. I'm going to select these two, and I'm going to weld these 2 points. So now, if I pick this, those are attached. And these aren't. And that's what I want. So that's a little primer as to how to weld and unweld edges. If you pick them and right-click, you can weld the edges. If you left-click, you can weld the edges. If you right-click, you can unweld them. So that's a way to work with that. So I'm going to grab this edge. I'm going to drag it up. I'm going to grab this edge and drag it down. And then I'm going to grab both of them. And I'm going to just drag them over using my manipulator. So now what I've done is I've opened up the edge of this model. Now what I'm going to do is I'm going to select all of these edges, and I'm going to extrude out, holding down the Alt key. I'm going to just Alt drag out the bridge, or half of the bridge, for the nose. If I toggle smooth, you'll notice that now I have my bridge area extruded. So at this point, I'd like to mirror this image or mirror this object so that I have something that I can evaluate to see how it's going to fit. So I'm going to apply some symmetry. I'm going to click here. I'm going to pick the fraction that I want for symmetry, and I always pick the wrong axis. So bear with me. And I did. I don't know why I'm so deficient in that, but I always wrong axis. Let me try this again. Symmetry across the X. There we go. And you'll notice when I made my symmetry, I've actually got a little gap here, and I want to fix that. So what I'm going to do is turn on my vertexes, and actually I can do that on the edge level. I'm going to grab my edges. I'm going to pre-select both of them, and I'm going to merge edges. Oops. All right, didn't like that, so we'll weld them up one at a time. So I'm going to pick these two verts, and I'm going to weld them. And you'll notice that it's switched to box mode, and this freaks out a lot of new users because what's happening is it's saying that it's unable to convert the object. Well, the reason it can't do that, you'll notice this red dot here. It's saying that this dot is connected, but there's a whole bunch of other stuff around here that's not allowing it to be valid. So what I'm going to do is I'm going to just continue welding this up, and you'll notice that my green symmetry line has appeared, meaning that this is now a valid axis of symmetry. So I'm going to weld that one up. Weld that one up. Now I'm pre-selecting these verts, and the reason I'm doing that is if I pick one, hit the weld button, and then pick the other, the first one jumps to the second one. If I pick this one, hit the weld button, that one jumps to the other one. If I pick them both at the same time and hit weld, they jump together or average their position, and that's actually what I want. So I'm going to pre-select both of these and just weld these up. You'll notice now that my green symmetry line goes all the way around the model. My red dot has gone away, which means that if I toggle smooth now, if I go to smooth mode, this should convert. And it does. So I've got a symmetrical model, and the beautiful thing about that is now I can grab an edge and I can modify it, and it happens on both sides of the model. This is fantastic for doing objects like this because obviously we want these to fit, and modifying one side will modify the other, and it makes it really easy to pick this stuff up. So the last thing I'm going to do, you'll notice here there's some topology things that are going on where this is kind of getting a little pinchy in here, and it's not the kind of smooth flowing layout that we would like. What I'm going to do is I'm going to go to my edit layout tool here, and there's two things that this tool does. The edit layout, if you have a problem with your model and I right click it, it's going to show you where star points are, key points are, or there'll be a little seashell icon that'll show up that'll show you if there's an error in your model that needs to be fixed, and it'll help you diagnose things as you get more advanced into this. The other thing is if I right-click on it and make uniform, what it'll do is it will kind of re-weight all the isoparams that are in this model, make sure that they're all having equal influence over the model, and you'll notice that it's improved the topology significantly through here. That's a good practice to get into as you're modeling things, to every so once in a while just use that right-click edit layout to relax your topology and make sure that you're not getting any areas that are pinching or anything like that. So in about 12 or 13 minutes here, we've created the frames of these glasses. So let's bring our head back up and see how we're doing. Obviously, it doesn't fit very well. So let's go to the top view and fix that. So the first thing I'm going to do is I'm going to, in object mode, pick the entire thing, and I'm going to move it in a little bit. And then this is something that not a whole lot of people know. You can use all of the Rhino deformation tools on T Splines objects. The thing to keep in mind is that you want to do it at the vertex level. And the reason you do that at the vertex level is if you apply the deformation to the vertexes, it will keep the object as a T-splines, as a piece of T-splines geometry. If I apply the deformation at the object level, if I go to the object here, and I deform this, it's going to convert to a Rhino object. You'll notice here it's a polysurface. I don't want that, so I'm going to undo that. I'm going to go to my vertex level. I'm going to pick the vertexes that I want to modify, and then I'm going to use the Rhino bend deformer. I love this. And I'm just going to bend this model. Super controllable, super efficient, super clean. And obviously, since the model's symmetrical, once I bent it, it mirrored it across the line of symmetry. So now we have this, and it's fitting fairly well. And again, I'm not going to go crazy on the details on this because, you know, this is a fairly advanced tutorial in our courseware training. But I did want to show you how you can create something like this fairly easily. So the next thing I'm going to do is go back to box mode. Actually, let's build the temples first. And so let's go to the side view of this model where the temples would be. And we're just going to build a simple Rhino curve approximately where the temples should be. And these can be any shape. I'm just going to kind of wing something in here. And then let's go to the top view. I'm always amazed at how many people don't know about this tool, but this is the curve from two directions. And I'm going to lay this in right in next to the head where I want this to lay. Something like that. Go to my perspective view. And for those of you who aren't familiar with this, this is a Rhino command, curve from two directions. This is really common in the automotive industry. It gets used a lot. I'm going to pick this. I'm going to pick the first curve. I'm going to pick the second curve. And what Rhino does is it combines those curves into a 3D curve that is generated based on the position of those two in each plane. So I've got a great 3D curve here now. And I'm just going to pipe this. Again, these are all Rhino commands. There's nothing spectacularly difficult about this. And I'm going to use, I'm going to make this kind of about this size here and kind of about that size there. I'm going to just make a pipe. Now, this is the capped Rhino polysurface, and for those of you who have been messing around with this, you'll realize if I try and convert this to a Rhino surface or to a T Spline surface, it won't do it because it's a polysurface. So what I need to do actually is pick this and explode it, and I'm going to get rid of the caps that were created when I piped this because I don't need them. The other thing that you'll notice is the curve from two directions tends to create a lot of segments and edit points and stuff like that in a curve. And there's way too much geometry going on here. One of the names of the games with T Splines stuff is simplicity is what you're aiming for. If you can do more with less, that's what you want because you're going to get smoother result. So let's go ahead and grab this. I'm just going to rebuild it using the Rhino rebuild. And I'm going to rebuild this with 6 points in the V, and I'm going to use about 14 in the U. Let's just preview it to see what it looks like. So that's a much simpler version of what I had before. I could have probably even gone less than that. Let me rebuild that again. There seemed like there was a lot. 14 seems like a lot. Let me change this to like 9. I really tend to try and get as simple as I possibly can. So this is still a Rhino surface. Get rid of that curve. And in order to bring that into kind of the world of T Splines, I need to convert this into a T Splines object, which I'm going to do just by hitting the convert button. And you'll notice that it converted it to a T Splines object, but it's identical to what my Rhino surface UV layout was. So now all I need to do is I need to join these two up. And, well, actually, let's cap this first. So I want to make the temple down here. I'm going to close this up. And this is one of my favorite parts of the tutorial, because if I pick this hole and fill it, you'll notice that I get this really great smooth end down here. And this would be a good time to run this right-click edit layout. And the end of this temple is something that every time I do this tutorial, I look at it and I think, man, that would be such a drag to try and model that in NURBS, because that was rounded surfaces like that always used to make me insane. So let's adjust the shape of this a little bit. I want to make this a little fatter at the end just to give it a little more kind of glasses-like feel. And you'll notice that you get just a really beautiful capped end. And we could subdivide this surface and do some things to get it a little cleaner, but I'm not going to worry about that right now. And this is a little fat compared to my glasses, so I'm going to grab these and I'm going to just scale them towards the center. Bring that down a little bit. Notice how nice and smooth this is maintaining itself along. And I'll just let that transition happen fairly naturally. And this is one of my favorite things about T Splines is you know, there's modeling and there's designing, and in previous modeling systems the two kind of never got to meet. You were either designing something then modeling it, or modeling something and hoping it was designed, or you know, but in T Splines it's like the input and the user interaction is so elegant and so easy to manipulate that I can actually go in and design this thing on the fly. I don't have a sketch, I don't have a plan, I'm kind of planning on finding the way along the way, and it allows me to be able to do that. So I've got my temple and I'm kind of happy with that, and I could do all sorts of crazy things in here, like I could move this and I could make it some kind of crazy Oakley thing or something like that, but I'm going to leave it fairly straightforward. And so I need to figure out how I'm going to hook this into here. And for that, I'm going to switch into box mode. And you'll notice that the edge of this model has the opening here has 6 edges. 1, 2, 3, 4, 5, 6. So to make my life really simple, it would be great if I had 6 edges. Let me hide the head here. It would be great if I had 6 edges that I could connect into. Well, where could I get that? 1, 2, 3, 4, 5, 6. Well, all I got to do is get rid of 2 faces, right? So let me grab a face. I'm going to grab this face and I'm going to grab this face. I'm just going to hit the delete key and get rid of them. Let me throw a different color on this just so that I'm afraid that this may be difficult to see. That didn't work. All right, anyway. So I've got edges here, and I've got edges here. And there's a couple of ways I can do this. The absolute cinder block simplest way is to do it at the vert level and weld. And remember in the beginning when we were talking about it, depending on how I pick these verts is dependent on how this stuff is all going to connect, right? So I want to jump the temple to the frame. So the way that I'm going to do that is I'm going to pick the first one, I'm going to hit the weld points key, and then I'm going to pick the second one. And you'll notice that the first one jumps to the second one. I pick this one, hit weld, and went here, it would jump. That's not what I want. I want this to go here. So I'm going to pick, hit the weld key, pick the second point, and it jumps there. Same thing with this one. Pick, weld, pick, weld, pick, weld, and the last two, pick, weld. So now I've just connected this piece with that piece, and if I toggle smooth at this point, you'll notice a couple of things that have happened. My green symmetry line has disappeared because I blew a hole in this over here. So I lost my symmetry. Actually, I take that back. I welded a piece of geometry that was on this side to here. There was no geometry over here to mirror it to. So I have a hole over here that's not welded to anything because there was no geometry over here. This temple was not symmetrical. So what happened was T Splines lost my symmetry. This is the stuff that makes new people crazy because it's just kind of stuff that's a little different than you're used to. If I toggle smooth, what's going to happen is the model's going to look awful, which is not what we're going for. Actually, that transition looks fairly good. But you'll notice over here there's all sorts of mess going on. Well, that's because there's a hole over here that's not connected to anything. So let's fix that. I'm going to go back into box mode. No, not make a box, box mode, smooth toggle. There we go. I'm going to grab my faces that are on the other side of the line of symmetry. I'm just going to delete them. Just get rid of them. And you can do this at any time. You can add or delete faces anytime you want. Now if I toggle smooth, oh, stop it. Sorry about that. My render button is close to my T Splines toolbar. Now if I toggle smooth, I get this nice transition. I have my open bridge there. So all I have to do is just apply symmetry back to this. I know my bridge for where my nose was is already set up, and actually I already even have my symmetry set correctly because I picked X here, so I know it's going to work for once instead of me picking the wrong thing and sending it off into space. So now I have our glasses. Let me shade this so that you can see. Get rid of my layers here. Let me shade this. I use the Oxpecker plugin. Everybody asks about this every time I use it. It was a free plugin. And for some reason that's not. Oh, because I'm in face mode. Object. There we go. Everybody always asks about this. This is a free plugin that was written by a guy named Highfoam on the Rhino website. If you just do a Google search for Oxpecker, it's around there if you want it. So now you'll notice that we have some really beautiful stuff happening here. Stuff that's really difficult to make in NURBS. We have an organic Y branch that has a beautiful highlight running through it. We've got symmetry, so if we modify this model, it's obviously going to update either side. We've got a smooth end cap. You know, try modeling something like that in NURBS. It'll make you crazy. I know it makes me crazy. And you'll notice how beautiful that was, and we just used the fill hole command. So in 30 minutes here, we've created a fairly complex shape that we can go back and modify. Let me bring my head back up. Stop it. Oh, come on now. My layer stack is not behaving itself here. At this point, I can look at my model and evaluate it and see, let me just go inside the model here and see where there's any fit issues. So you'll notice that it doesn't look like I'm colliding anywhere, but maybe I need to improve my fit a little that it's touching. the head. So I'll grab an edge, and I'll just slide this in a little bit. And if I zoom out a little bit, you can see that that's actually adjusting on both sides. And looks like the temple is sticking out a little bit. That wouldn't be terribly comfortable, so let me slide that in a bit. I'm just going to grab these edges and slide those in, noticing that it's updating on both sides of the model. Okay, this is stuff that would make you nuts and nerves trying to adjust this. You'd never be able to do it this easily, and it would never come out as smooth because you'd have to go back and reblend everything. So that's the basics of what the, how to create a form like this. And if you wanted to get into the nitty-gritty and add the more details and stuff like that, we could extrude, channels for the lenses and all sorts of stuff like that. But I wanted to focus basically on how this was created. And if we review the steps, we started with a curve, a single curve. We extruded the frames. We pulled this apart and mirrored it to create the bridge section. We used a couple of Rhino commands to create a curve going in one direction, a curve going in the other direction, combined them, made a Rhino pipe, rebuilt it, converted that to a T Splines object, and then just welded that to here. And you get this beautiful transition. And it looks like under 30 minutes we've created something here that I know from experience this used to take me, well, let's just say a lot longer than that to create something like this. If we wanted to get into details like adding, some bridge for the nose or something like that, it's simply a matter of grabbing this stuff and moving it. We could bring it in to add a little bit of nose pad in here. Go inside the model to see where it's hitting. Slide this in a little bit. There we go. See this starting to contact. So I'm going to leave that one up there. I'm going to grab this one instead. Pull this in until that contacts. There we go. So you can see how you can just interactively change this stuff. And in objects that interface with humans, or if you were doing shoes or glasses or anything like that, this is how you could sit there and just visually fit stuff so that you'd have a much better chance of your first rapid prototype model feeling good on your face than it would be if you just winged it. So that's pretty much what I wanted to cover today. If there's any questions or anything like that that I can address while I'm rolling along here, I guess now would be the time to ask. Tom, is there anything that's popped up here that I can address verbally?
It looks like we've answered most of the questions. If anyone has any questions, feel free to type them in, and yeah. Okay, so here's a question. How applicable would this be for hand tools and over-molded grips?
This would actually be an absolutely fantastic way to do that. The way I've actually used it for exactly that tool. Or for exactly that application. And what I typically do is we'll get a hand buck, a 90th percentile human hand, and pose it. Create the thing in Poser, create it in whatever that you're trying to work towards, and then build the model inside the the space of the hand, and do just this system where you turn around and you go inside the hand and pull the T Splines model until it touches the hand, and you'll know that it's almost custom form fit to go in there. I've done this for skates too. I had a client that was doing inline skates, and we put a foot last inside the skate. I went, flew the camera down inside the foot, and then pulled the outside of the skate until there wasn't any collisions. And actually the very first prototype fit really, really well. I think we only did 1 or 2 revisions on that to adjust fit issues, and those were all done, with T Splines. And so the modification, the fit modification, took about 35 seconds as opposed to having to go back and actually cut a patch and add some relief and stuff like that. So it was a really elegant way to handle that.
Great. So the next question was, how do these models shell in an application like SolidWorks?
Brilliantly. These are really clean, really nice watertight geometry. And for example, my business partner, Kevin Pasco in Los Angeles, built a toy pony, a lot like, I don't know if you're familiar with Hasbro's My Little Pony brand, but we were doing it as a case study, and he built a pony in T Splines, and we were actually able to shell that fairly easily in SolidWorks. So it was something that was very organic and very complex, shelled really easily.
Okay, and then we had 2 questions about the modeling. One of them says, what if one wants a small thin groove in front of the frame around the glasses? And the other one says, could you try to crease some of the edges?
Sure. Well, the creasing of the edges, let's go and let's add a little detail in here. And what I'll do is let's insert an edge so that we can, I'll pull out a little, like a little, graphic detail here. Let me get rid of this. So I'm going to insert an edge. I'm going to click here, right-click to accept, and I'm going to put an edge, kind of, we'll just call it right there. Model will update. And if I were to crease this, which I don't particularly like crease myself. I'll do it, and then let me show you why I don't like crease. So that's here. So now that's creased. And if I pull this, you'll notice I get a nice sharp edge on there. Now, the thing that you need to remember about crease is it takes 2 faces for crease to fade out. And if I shade this, notice my original model, my original crease is here. Okay, here's my original face that was creased. Notice on the model, here's the second face. Let me turn faces on so I can. Here's the first face, here's the second face. If you'll notice, we'll come in here a little bit. My crease started here. It went all the way through this face, and it went halfway through this face before it dies out. Creases need 2 adjacent faces to disappear. So if you are wanting to crease a surface and have the crease be localized here, it's not going to happen. What's going to happen is the crease is going to have a value of 1 here. It's going to go from 1, I'm making this up. Tom is probably cringing at me doing computer math here as an art student, but let's say this crease has a value of 1 throughout this entire surface. It has a value of 1 here and a value of 0.5 here, and then it has a value of 0.5 here and 0 here. So if I shade this, you'll notice that the crease starts and then it takes 2 entire faces for it to fade out. That's fine if that's what you want, but the problem, the reason I don't particularly like crease is because it gives you a mathematical crease. I mean, it's a sharp edge or a knife blade, essentially. And in things like glasses or something like that, that's not exactly, that's not really what you would want. There's very few instances in a product design where you want something that's actually going to be sharp, because if you zoom in on any object that was made on any type of modern production equipment, it's going to have a teeny tiny fillet on it, even if it is a really teeny tiny fillet. And crease doesn't give you that. Crease actually gives you a sharp knife edge. What I would do instead here is I would insert a couple edges. Grab my edge tool instead. I would grab an edge here. I would insert a couple of edges. So maybe one here. And then in order to get that sharp edge on there, I'd insert another edge. I'm going to use both sides, and I'm going to insert one, say on either side of that. Oops. Like that. And go there. Maybe not. It's not liking that. Let me try inserting them one at a time. Okay, I like that better. Insert another one up here. Now if I pull this center point out, I'm essentially going to get the same effect that I had before, but it's going to be much softer. And I can control how sharp that is by going into my vert level. I can pick this vert and I can have it die out faster than a crease. So I can really isolate that detail, whereas in a crease has to have two faces. This I can isolate it to be just where I want. So depending on the effect you want, that's the difference between if you wanted to use a crease versus inserting an edge. And I typically like to insert edges as opposed to creasing, just because what I was talking about before is I don't like knife edges on stuff, especially that has to interact with humans, and especially in this case where it has to interact with someone's face. Now, you could say, well, what if I wanted this to be sharper? Well, then that's a matter of just picking this and changing the weight using the TS weight command. Right now it has a value of 1. Let's change it to 3. You notice that sharpens up considerably. So you still get a nice hard edge, but it's got that teeny tiny fillet on the end that keeps it from being a knife blade. The other thing about this is if you avoid knife blade kind of situations, your models are going to look better when they're rendered, because one of the biggest tells for something that's a CG model is edges without fillets on them. It just makes them look too crisp and too hard, and it's one of the things that make your models look CG. So I tend to like using weight, insert edge, and add weight and stuff like that in order to get nice soft edges, and then they render nice and they look more realistic actually. How? What else we got?
I think we've been keeping up. There's one more question here about if you're using different weights in T Splines, do you get the same problems when shelling as you do with NURBS?
Nope, not as far as I know. Tom, actually, maybe that's a question for you. I haven't run into that myself. And again, I'm an artist and Tom's a computer scientist, so he may have a lot better information than I do, but I haven't run into it in my own practice. I've been throwing weights on stuff and converting it to NURBS and then having it shell no problem. So,
yeah, there may be problems. I know that when you've got weights on a T-spline, those transfer into weights on a NURBS in the same way.
Okay.
So, I mean, it depends on your sheller, I guess. I don't have much experience running shelling algorithms, so.
Okay.
Yeah, but like you could try and see. Yep. Okay, are there any other questions, or I think if there's not, then we'll probably just say thanks, Kyle, for the excellent demonstration.
Great. Well, thank you everybody for coming. One last thing I wanted to mention, and this is in the shameless plug of T Splines department, and you have to realize that the stuff that you can do with T Splines is stuff that you cannot do in NURBS unless you are a heck of a lot better modeler than I am, which I guarantee you there's people out there. But in order to try and build something like this in NURBS in 30 minutes, you would have to be unbelievable. You'd never be able to modify it, you'd never be able to update it, and all that kind of stuff. The thing that you need to keep in mind is that a seat of Rhino and a seat of T Splines is cheaper than a seat of Photoshop. If you look at what, the new Creative Suite Unlimited, or what Photoshop is charging for a seat of Photoshop, which everybody has, this is cheaper. It's a cheaper thing. So it's a really incredible tool for a really unbelievable price. And my personal opinion is that you guys should grab this before the T Splines guys come to their senses and realize that they should charge a lot more for it. It's really transformed what I can do. It's really transformed my modeling and the quality of model that I can apply, and the amount of time I can do, and the end result that I'm able to deliver to my client. It's been a huge tool for me, one that I'm going to continue using and continue to help to develop. And I hope everybody just realizes the price value of what you're getting when you get this. It's a little daunting when you first start trying to get into it, but as your learning curve starts to flatten out, I think you're going to come to the same conclusion that I did, which is that you can't believe that they sell this as cheap as they do, because the amount of power that's available here is really fairly unlimited. So that's my shameless plug, and I say that, yeah, I work with T Splines, and yeah, they pay me, but I also say that as a user and a product design consultancy owner, and it's something that's really transformed the type and quality of model that I'm able to deliver to my clients. So I hope everybody out there recognizes that.
Hey Kyle, it looks like we got one more modeling question. It was, how difficult would it be to add tapered dents in the surface similar to a hood scoop or vent?
Well, that would be really easy. You can, I'm assuming that we're trying to talk about like a Oakley style hole or something like that. And there's a couple of ways that we could do it. One would be to just pick two faces and bridge them together. And we can do that really simply. Let me hide this. And I'm going to kind of just wing this. But let's just open this face up, and we'll just make this face a hole. I'm going to just bridge. I'm going to go from the face mode. I'm going to bridge from here to here and check to make sure that all my directions are correct. And I'm going to use two segments just because I want a little bit of control over what the shape of that thing looks like. And I'm going to hit go. And it made me a hole. Grab this edge. And I'm going to scale this edge in just a hair. And maybe I'll grab this one here and move it in a little bit. And maybe I'll scale that edge just a hair too. Again, I'm completely winging this, so. And let's toggle smooth and see what it looks like. And I think that updated. Ooh, sweet. It even updated across the line of symmetry. So, all right, let's toggle smooth that. Yeah. Look how gorgeous that is. And then it's just be a matter of adjusting if you wanted this to be, you know, scoop-like. It would just be a matter of adjusting your edges out. Very, very Oakley-licious. How you like it now? Let's go, and I'm just going to edit layout here. Right-click on the edit layout to just double-check my topology, but that looks really good to me. Take this one. Punch that out a little bit. Now we have a scoop to cool the inside of your ears. How's that?
Hey, it looks great, Kyle. Okay. Let me see if there's anyone that has any other questions. Now is the time, or we'll probably end things off.
Fantastic. There was one comment here about silo. Yeah, silo is great and all, but it doesn't convert to NURBS. You have to use something else to convert to NURBS. If I want these glasses to be NURBS, this is the thing that you have to keep in mind. If I want this NURBS, I right-click on the convert button, I click here, and I get NURBS. This is now a watertight Rhino polysurface. If I check the naked edges, it's got none. So this is Bomber, Rhino, NURBS data. You can see this SLA, you know, all that kind of stuff. So there are a lot of other sub-D modeling softwares out there, but this is the only one to my knowledge that has that type of interoperability, you know, with the one-click button to NURBS and all that kind of stuff. So not to beat up on silo or anything like that, but you know, for me, I live and die in the NURBS world because I have to work with engineers and stuff like that, and for me, this is, you know, kind of where it's at. So.
Okay. Well, great. I guess we'll probably just stay on and answer any questions that come up, and yeah, thanks a lot, Kyle.
Fantastic. Thank you, everybody.